All right, guys, let's talk about interfaces. Interfaces are a similar idea to abstract classes, but they're sort of more basic. Use an abstract class if you've got a bunch of things that have a bunch of common code, but they also have a bunch of things they do completely differently. Um, for an interface, you've got multiple things that um, sort of do the same kind of thing. They could be very similar in function or very similar in idea, but their code, how they're implemented, is just completely different. There's two things you can put in an interface. One, you can have, by the way, this is an interface called Weapon, which I made for one of my programs. It's the game template, which it's earlier on in the Google Classroom if you want to check that out. Anyway, so making an interface called Weapon. One of the two things you can have in an interface is constants, a static final constant. Notice IntelliJ is telling me I don't need to say final or static because it's just guaranteed to be static and final because that's the only thing you can put in an interface. So you can have constants if you want, like pi or whatever. If for some reason you need to have that, you can do it. But people usually don't even bother with this unless for some reason it makes sense with your program. The real reason people use interfaces is one, to get the common reference. Just like with the abstract class, I could make an array of weapons. I can make a function take a weapon as as an argument, as a parameter. So anything that implements weapon can be put in its place. So having that common reference is super useful. And the other thing is, it's an interface is basically a contract saying, hey, I'm guaranteeing I have these methods. So you don't have to write abstract this time. It's a bunch of method headers. Oh, don't want to do that. So right here, I've got a get damage. Every weapon, you should be able to get the damage of it. That depends on the player and their stats. You got to get a power level. That's useful for sorting them into like which one's better than the other. We've got to get costs, how much they cost to buy in the store. We've got a get name method, and we've got a reload method, which for swords doesn't matter so much, but it still exists. All right, so let's take a look at sword. So sword, notice you extend a class, you implement an interface. And you can actually implement as many interfaces as you want. So you can keep putting comma. So this could, I could do another interface, whatever. So you could just keep going. Keep adding as many as you want. You're just guaranteeing more and more methods, more and more functions that need to be in your class. So this has a get damage function. It's got to get power level. It's got to get name. It's got to get cost. It's got to compare to. One thing I didn't mention when we were going over the interface was this was extending comparable. By the way, interfaces can extend as many other interfaces as they want, and just comparable guarantees a compare to method instead of guaranteeing 5 methods. Comparable just guarantees 1, compare to, but it's a very useful one. So I was required to have that one in sword and gun and all that other stuff because otherwise I'm breaking contract. This extends comparable. And again, we can keep adding more interfaces that we want to extend. Whatever. Just comma separated. So sword has it. That extends, or it implements weapon interface. Gun implements weapon. and it's got the get damage, it's got the get name, it's got a couple new ones. It's got get cost, get power level, compare to, all that goodness. Machine gun, extends gun. Some stuff it doesn't have to implement because it just keeps the same value as gun. It's got a fancier get damage because it can fire more than one thing at a time. Its power level is also a bit different because it's got a burst size. Yeah. So interfaces are pretty darn useful. Here's one example of it in action. So in the main method, to load the store's inventory, I go in and shove all these weapons in there. I've got the Sky Splitter, the Devastator, the hand cannon, the dueling gun, the rapier, the Excalibur. They're all ridiculous. Now, they all fit in here because it's a weapon array, and a sword, since it implements weapon, it is a weapon. It can use a weapon reference. A gun implements weapons, so it can use a weapon reference. A machine gun extends gun, which implements weapons, so it can also use a weapon reference. So these all fit in a weapon array, so having that common reference is very useful. The whole polymorphism means that if you just tell a thing to get damage, it'll go and figure out what the right get damage, it'll use the appropriate get damage function for the actual object in memory. You can also do this. This is kind of fun. So one great instance of one really useful thing that's very different for a lot of different things, but has a sort of commonality, is the idea that you can sort things, that one thing is greater than another and one thing is lesser than another. And to guarantee that we had that, we implemented comparable. So that extending comparable and implementing that compare to method means that we can use methods designed to sort and from least to greatest. And so I can just shove these weapons in various orders. Excalibur should be the best. Hand cannon, I think, is like third best. Sky Splitter is second best. Notice they're all out of order, but not after this. This will sort the array, so the weakest weapon is at the 0th index and the strongest weapon is at the 5th index, and they're all in order. And it does that using the compare to method to figure out what's bigger than another. Integers have this, strings have this, strings sort alphabetically, all that. So compare to is super useful. Anyway, so those are interfaces. I just wanted to show you one of my favorite examples of this. I'm probably going longer than I should, but hopefully it's worth it. So we're going to learn about two memory structures, two data structures called linked list and array lists. And they all implement the list interface. So here's the header. And notice all it has is a certain number of methods that it guarantees. So it's got lots of comments, but really, if you were to strip away the comments, it's just guaranteeing a couple methods. So all lists must have these methods, and that's it. That's all that's in there, barring some random junk. Now, if we go to array list, which is one version of list, it is made to hold the same kind of stuff you'd put in an array, but you can like add stuff to it. You can search for items in it. You can remove items from it. So it's like an array with a lot of extra functionality. Now, it does this with an array in the background. So it secretly has this array and it loads all stuff in there. So if we scroll down, it's got, well, let's go to the header first. Notice it extends abstract list and implements list. So that's what we want to see. It implements list, so it's guaranteed to have those certain methods. Things like last index of, or toArray, or get, or other exciting things. A linked list has exactly the same functionality. It's like an array, but you can search for stuff, you can add stuff to any place, you can remove things, it can change its size. But instead of having an array in the background, it's got this funny memory structure where each little item in the array points to the thing right before it and the thing right after it. And so you got to like go along the array to find stuff, but it's really easy to add stuff in the middle. Only part that really matters is it's completely different in how it's coded up. So it still implements list. And so it's got things like remove entry, get last, remove first, but its remove first is completely different in implementation to an array list remove first, or its add is completely different than an array list add. So two completely different ways, completely different implementations of accomplishing the same task, but because we use this array, we can have one common reference. We can have functions that just take a list of any type, so you could use whatever list makes sense given what you're trying to do with it. And yeah, no common code, but certain guarantees of methods, so you can use them interchangeably wherever you want. So that is interfaces, and hopefully that makes some sense. Be well. Talk to you next time.